As I'm the last speaker of the day, I promise I'll be brief. And let me first introduce myself. I'm Kilian Anheuser from FAEI, the scientific laboratory of the Geneva branch of the Konchalovsky Foundation. Right. As I only learned about 90 minutes ago that I'm supposed to give a presentation, I don't have any audiovisual support with me, so we can turn off the slides and projectors. So what I'm going to do is the stand-up comedian thing and just tell a few stories and to give you an idea what we do, how we work, and what sort of results you can expect. I'm very grateful to Denis Lukashin and his colleague for having set the scene, because now you know already what the work of a scientific laboratory is about. And so when I'm at a party and people ask me, what do you do for a living? I say, well, I'm a chemist by training, and I work for a scientific laboratory that does technological analysis of paintings and other works of art. And then the inevitable answer is, aha, so you do dating and spotting fakes, don't you? And of course, this is part of it, but it's really spotting fakes is not where it stops, but more often than not, of course, you do have fakes, but you have all sorts of, you also have entirely authentic and well-preserved objects, paintings or other objects, but you have anything in between. You have heavily restored pieces where there's very little original material remaining, and where most of the paint layer has been added by a conservator. You have, when you go beyond paintings, you have ceramics, archaeological objects, applied arts objects that have been put back together from shards with an entirely artificial surface created by the conservator, and then it would be difficult to say whether this still represents an original or not. And it is our job at technological laboratories like the one in Geneva, like the one of Denis Lukashin, and there are others in Europe and the world. It's our job to explain what has happened. Let me tell you another story. Some time ago, I attended an international conference. It happened to be an archaeological conference, but it could have been any conference about works of art or cultural objects. So there was an issue about the provenance and the cultural context of a particular object, and the experts couldn't agree. So one archaeologist suggested, why don't we give this object to the scientists? And they put it through all their machines and their black boxes, and they give us the result. They tell us all about it. And this is a very common misunderstanding. So it doesn't work like that. But of course, sometimes you can tell straight away, this is a fake from beginning to end. This is modern when it should be 18th century, 19th century, early 20th century, or whatever. But more often than not, the result of our work, the technological analysis, is rather about providing elements that are then discussed with art historians and conservators who have an important contribution to make, especially when it comes to the conservation history of a piece. Because Until very recently, then very little conservation work has been documented. Museums have objects with essentially no information about the conservation history, and it's even worse with private collections, because usually private collectors find conservation work expensive enough, so they don't also want to pay in addition for detailed documentation of the intervention. So anyway, typically at the end of a complex project, I'm not talking about simple projects where you just look an object and you can tell straight away that it's not what it's supposed to be. But at the end of a complex project, then you bring together experts, the scientist, the conservator, but also the art historian, and they discuss all the evidence. That everyone brings in the evidence from his or her field, and it's only at this point that final conclusions are being taken. Now, how do we go about the analysis? We've just had the question about what size of sample does it need. Well, first, the first thing you always do is to put an object under the microscope, the optical microscope, and you have a good look at it. And then you can also already characterize the way the painting has been applied. You can tell about how the painting has been physically constructed with a canvas, whether it's been relined or not, and you can tell something about the state of conservation. This is often also a question: does this particular painting or other work of art need conservation, or is it stable? And this assessment you can do at the same time as the initial assessment for the technological study. And then you have all sorts of non-destructive methods. And, you have X-radiography that you all know from its medical applications. This gives you, for example, it tells you about the distribution of lead pigments. Lead is a heavy metal; it absorbs strongly the X-rays, and this is a good way to characterize the way to apply the pigments. You can do infrared reflectography, which is a way to look through the visible paint layer at the underdrawing. There are some pitfalls, but there's no time to go into details now. But if the underdrawing is black on a light background, you see it very well. If it's been executed in red with red ochre, which is often the case, then you can't see it. So if you can't see anything, it doesn't mean that it's not there. But this is a general problem. You need to have the experience, and you need to know about the materials and how they were used. So anyway, you do some initial tests and analysis, and only then you decide whether you need to take samples or not. And it's sometimes it's a question of budget, how far you go, because you can, in theory, you can spend endless time on any particular work of art. And the question is it worth it? Is it worth it in terms of the market value of the painting? Also, is it worth it scientifically? Can you not answer the questions with some simple analysis, and then you don't need to take it any further? Anyway, there is this joke about the scientist who tells the collector after the analysis, well, I've got some bad news and some good news. The bad news is we had to cut a big hole right in the middle of the painting to take the samples for analysis, so you won't recognize the painting. The good news is it was a fake anyway, so it doesn't matter. So anyway, so this gives you an idea of what we do in Geneva, and I think, given the fact that it's already 6:30, I'll stop there. And of course, I'm very happy to take questions in English or in French, and for Russian, I will need translation.